Now we are discussing about two trials of mass m and 3m are connected by a spring. They are compressed and released. Due to this process, they are moving in opposite directions and coming to rest after covering the distances of S1 and S2 respectively. If the frictional force acting between the trial and the surface belongs to two trials is same in both the cases, then the ratio of distances travelled by the trials. This is the question. Okay, I am assuming it is travelling a distance of S1 after compressing and releasing, and this is covering a distance of S2. So here generated frictional force F2, here generated frictional force F1. These two are equal. Coefficient of friction not equals to 0. So some friction is existing in between the surface and the trials. So this is our question. We are finding ratio of travelled distances. We are getting 9:1. Okay. We are compressing and releasing. This mass I am taking as m and this mass I am taking as 3m. So after compressing, I am assuming X compression created. After one is going like this, after another one is going like this. After releasing. Okay, now I am taking work energy theorem. What is the work energy theorem? We know. According to work energy theorem, now I am applying work energy theorem concept, formula. According to work energy theorem, what is the work? Work equals to change in the kinetic energy. That is the formula. Now first I am taking mass m, trial I am taking. So in this way compressing and releasing. So due to this, it is travelling some displacement of S1. So work equals to change in the kinetic energy. So after compressing, just releasing, it is moving with some velocity now. That velocity I am taking as u1. And the final velocity becomes 0 because it is coming to rest. Same concept here also occurring. Initial velocity of compressing, just releasing, is going with u2 velocity. Final velocity v2 equals to 0. Velocity is the velocity and displacement are the vectors, so having directions. We know that thing. Okay, now I am applying work energy theorem to first thing. Then what happens? I am taking W1. W1 equals to change in the kinetic energy. What is the change in the kinetic energy? Initial kinetic energy minus final kinetic energy. So, what is the formula for work? Force into displacement. Here, how much frictional force created? F1 created into S1. So, that equals to initial kinetic energy of m u1 square minus of m, final velocity is 0, so 0 square. So finally I had got F1 S1 equals to half m u1 square. This is my first equation. Now I am going to second trial. You take 3m. In this case what I am doing, same story where up. So the work I am taking as W2. So W2 equals to half into mv square. So 3m into u2 square minus half into 3m into 0 square. So what is the formula for work? Force into displacement. What is the force? Frictional force. What is the frictional force? Slightly more than that force. If you apply, it slides, it moves. So that is the concept. So applied force equal to slightly more than the frictional force that we are taking. So F2 into travelled displacement S2, that equal to half into 3m into u2 square. This is my second equation. Now I am doing 1 by 2. 1 by 2. This implies F1 by S1 by F2 by S2, first by second equations, that equals to half m u1 square by half into 3m into u2 square. Half cancel, m cancel. Here frictional force cancel because F1 equals to F2. That condition he had given. So now what came here, S1 by S2 equals to S1 by S2 equals to u1 square by 3u2 square. This is my third equation. Okay, again this is totally my system. I am applying law of conservation of linear momentum. According to that, before collision total momentum equals to after collision total momentum. That we are taking. Okay, now then. Now we are applying next formula, that is according to law of conservation of linear momentum. What is the formula generally? M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. This is totally my system. Before leaving, what is the velocity? U1. So, M into U1. Before leaving, what about this velocity? U2. So, I am taking this direction is positive. So, automatically this direction negative happens. So, you take minus M into U1 because velocity is a vector. Similarly, plus 3M into, what about U2? U2 as it is only. This is before collision total momentum like that. After collision, what happening? After these two final velocity is 0. So, this becomes 0. So, this is the process. Okay, now this implies 3m u2 equal to m into u1. M cancel. Now, 3 equals to u1 by u2. This I am taking as fourth equation. Now, I want third equation. What about third equation? S1 by S2, that equals to u1 square by 3u2 square. So, this I am writing as 1 by 3 into u1 by u2 whole square. So, S1 by S2 equals to 1 by 3 into u1 by u2 I am writing as 3. So, 3 square writing. So, what happening here finally? 1 by 3 into 9. 3 ones are 3 threes are. We had got 3 by 1. So, S1 is to S2, that equals to 3 is to 1. So, that answer is not correct. What you are given 9 is to 1. This answer is 3 is to 1. So, in this way we are doing. This is the process. So, in simple way you remember masses are m, 3m given. So, reverse way you take displacements. 3m is to m. So, 3 is to 1 coming. In that way also you take. Simple trick. Without doing all these things, simply remembering mass is inverse state for like these conditions. If frictional force same like their conditions only you apply. S1 is to S2 equal to 3m is to m. So, 3 is to 1 coming. Simple way.